Okay, so let's have a little video on this one as well. So we had a equals r bracket 1 plus I to the n minus 1 all over I in our last ones, okay, where we said we're going to have some regular kind of deposit, and at the end we're going to have some amount at the end of the investment. And now we're just going to flip the formula around, and you don't have to know how to flip the formula around. So, but basically we're just going to move things over, multiply both sides by I, and then we divide both sides by this big huge bracket, and we end up getting r on its own. Okay, and this is really important to remember what these things actually mean. Okay, and I is the one people get mixed up on. Interest rate is a decimal divided by the number of compounding periods per year. So here's one with Anya. Okay, she's in grade 11. She wants to own her own car when she goes to college. She plans on spending about $8,000 on the car. She finds investment make regular deposits for 3 years at 6.5% compounded monthly. So how much must the deposits be? So how do we solve this? The first and most important thing is to identify the variables first, and then you need to write down the formula. So the amount she wants at the end is $8,000. The payments we don't know, that's the regular payments, that's R. I'm even noting separately the number of compounding periods per year is 12 because it was monthly, the number of years is 3, and then we can work out I. Remember, I is the interest rate as a decimal divided by the number of compounding periods per year. 0.0625 divided by 12. And you'll probably get 5.2 times 10 to the negative 3 on your calculator, 5.2e negative 3, which just means 5.2. It's in standard form. It just or scientific notation just means 5.2 is over here. It means the decimal belongs negative 3 or 3 spaces to the left. 1, 2, 3. So that's what happens if you get this weird 5.2e negative 3. You know it's not 5.2. It's got to be smaller than that. You got to move the decimal places, the number it says, and negative means to the left. N is number of years times the number of compounding periods per year. I guess I should have written that as 3 times 12 instead, sorry, equals 36. I'll change it in a minute. So we've got the formula, and what are we going to do with that? So I thought I'd write the formula over here as well, and I changed around. The number of years times the number of compounding periods per year is just the way I like to do it in that order. Okay, so we had the two formulas. This is the one at the top here on the right that we used last time. And now it's the new one because we want to find R. So you could just use this original formula, it doesn't make a difference, and then keep going through until you find R on its own, or you can use this version, okay? So we're going to substitute instead of A, and that's why we have it written down here already, we put 8,000. Instead of I, we're going to put 0. Where did I put it? Equals, I lost it here, 0.0052. I had it on the other screen, okay? And you could put it all up in here, 0.0625 divided by 12, but it gets too confusing for me, so I like to break it up a little bit. 0.0052. Do not round this very much. All right, don't leave it as 0.005. We want to try and not round it too much. In fact, we go when we're dividing into something called significant figures, meaning there's two numbers that aren't zeros. All right, so I want at least two numbers that aren't zeros. I don't want to round it very much. And then on the bottom we've got big brackets. 1 plus I was 0.0052 to the power of n was 36. And that's why I work straight down the page. It's easy to follow. Minus 1. I just put everything I see down here. And I can keep the R equals if I want to as well. I suppose I should have put that more in the middle, equals. All right. And we work ourselves down. Now you can do it bit by bit. R equals, and let's do the top. So we got 8,000 times 0.0052 is 41.6, and we do the bottom, and you do it a little bit at a time if you want. 1 plus 0.0052 equals to the power of 36 equals, and by the way it's 1.205283683 minus 1, and then we get that horrible looking decimal now, 0.20528. Try not to round very much. So then R equals, so I like to do 41.6 divided by whatever that was. So if you can leave that in your calculator, it's even better. Or if you're using Excel, just do over the other one. So I'll do that in a second. 41.6 divided by 0.20528, and I get 202.65. Sorry, out of time I can't do it in Excel. I will in the next one then, okay?